she doth teach the torches to burn bright. It seems she hangs upon the cheek of night, as a rich jewel in an Ethiop's ear, beauty too rich for use, for earth too dear. So shows a snowy
Falcon.
dove, trooping with crows, as yonder lady o'er her fellows shows. The amp designer at Gibson, what made him call this amp the Falcon? One must wonder. When I think of a falcon, I think of a fantastic bird of prey with sharp eyes and a shriek that lets all around it know you can run, but you cannot hide. A fierce hunter, one of note of the bird species. The falcon will get what it wants, is unbeatable. The falcon is a majestic animal with a killer instinct, greatness inside. Yes, the falcon is a mighty creature, one we must respect and one we must set free. Okay, we're just going to take a little pan around it. As you can see, this is a 1964 Gibson Falcon GA19RVT, and we're just looking at the controls. One of the cool thing with Gibson is they were earlier than Fender to come out with an amp that had reverb on board alongside tremolo. And when I think of amp collecting, and I think of having a Gibson to add to the collection, I can think of no finer model to get than the Falcon. It's loaded with everything you could possibly need. It's got your volume, it's got tone, it's actually like a moonlight tone where bass and treble left and right. It's got a reverb, and it's got a wonderful tremolo on it. It's a grid adjusting tremolo with cathode biased output tubes to give you that olden day sound. It's got a beautiful jewel light, and it's got a fuse, no standby on this, it's on off, and it puts out about 15 watts. It's got 6v6 output tubes. And we're going to go around to the back. Everything's in really good shape for its age. Little bit of Tolex scratching there. They use this kind of wood grain Tolex, and we see that part of the N in Gibson has been smacked off, which was not uncommon. I saw a lot that would get sort of wrecked, even from the Gib onwards. So it's better to own a Gib Soy than a Gib, in my opinion. I think there's more value in owning a Gib Soy. Gibson, just like Fender, are a great amp to date because they use components that have date codes, unlike Trainer. And so from this reverb driver transformer here, we see that it's the 16th week of 1964. Heading over to the output transformer, we see that it's the 22nd week of 1964. A nice match there. And for the power transformer, we see that it is the 15th week of 1964. Down to the reverb driver, and we see the 25th week of 64. So I would put this amp somewhere mid June-ish of 1964. It's got a replacement speaker in it. The speaker it came with was completely blown, and had many holes and cracks in it, and was poorly repaired. We might have a look at it later, just to revisit the sadness. But this is a nice UK-made Celestion greenback speaker, 20 watts, and they were built very well. So I think this amp being a 15 watt, this 20 watt speaker is a awesome match for it. Normally kind of like to double, so a 30 watt speaker would be ideal. Nice made in England Celestion there. You don't see too many of those anymore unless you're buying like gold or blue or ruby, I believe, are the UK ones that are left. So nice little complement of tubes, which are, I guess, I don't know, semi-unique to Gibson. From what I've seen, maybe other amp builders use them, but 6 EU7s. They used 3 of those, and they used a 6C4 as the phase inverter, and then 2 6V6. These are Russian 6V6s. We'll take a look at those later. I'll pop them out. And then the good old 5Y3, and that's an RCA, nice old RCA 5Y3. It's going to be interesting to note, you know, the difference in stability in an adjusting bias tremolo, which sounds awesome, with cathode bias output. So this will be really cool to get into. Basically, when I got it, I did take it apart. This was before I was filming anything, and all the resistors were reasonably within spec. They were all falling. I think the worst outages were like 12.5% out, and I usually follow a 10% outage rule when I replace a resistor. But because most of them were in spec and the worst case scenarios were 12%, I was just like, no, let's keep this original. So changing the old electrolytic filter cap, yeah, that was a smart idea. This is the tone sucking network, as they call it, this very odd voltage capacitor, voltage divider, resistor capacitor type thing that, like, I don't know, I think someone at Gibson just made up one night. Like Doc Brown fell on the toilet. When returning to, he saw this in his head, like the flux capacitor, only this didn't exactly go in a DeLorean. So these were some radial caps that were replaced. They were radials. I didn't know the age. I didn't even bother. Let's get them into axials. So I did. And then some little 25 UF cathode bias electrolytics. Just went ahead with it. Can't remember why this guy got changed, this little cement. But, oh yeah. Yeah, we'll get into the schematic a little bit. But this this value is like 0.001 or something like that, or even lower. And well, actually, let's look. So one of the things is that's not allowing a lot of bass to pass. It's passing way too many highs, choking off the bass, and so to change to a 0.02, you're allowing more bass and you get a fuller sound. So this was this came in really nicely original condition. All like that makes everything worth it. You spend a little more, it's costly, the shipping, and when you get it, I mean, boy, if you can get it and see that it's very untouched and very original, it's worth paying the extra money for. So what we're going to do today is I wanted to really take it slow with this whole Gibson Falcon, and yeah, it is a mod, and it's a necessary mod. I played it clean, and again, I didn't record that. When I got it, I played it in its very original 2-spec state, And it is thin. It's everything that you read about them from owners that you know, they have a little bit thin sound to them, and so you know there's a lot more heart in this amp that you can bring out. And so many people have documented the changes, this being one of the biggest ones. This is the what they call the tone sucking network, and that was this weird orange 3-leg. It's been called a couplet. You know, I don't know. It's a weird thing with 2 resistors and a capacitor, a bypass capacitor inside, heading to ground. So through another capacitor, another small one. It really chokes off your tone, and it really is not good. So just removing that alone brings improvement. This 0.001 coming out of the plate of the input, the first input preamp stage, this again is not allowing bass through. So change to a 0.02 makes sense. I did not touch this bypass capacitor for the cathode. It comes stock as 20, which is pretty much fine. I mean, 25 you're going to get most of the signal through, so I didn't really see a need to do that. Now what I've highlighted here is the changes we're going to make today. Now I stopped with these 2 simple changes because I wanted to hear how much of a dramatic improvement that was. And what I found is it improved the amp quite nicely. All of a sudden I did get more bass through, so now I've got some nice fuller tones. Removing this, absolutely. Volume went up, tone went up, it was a much fuller amp. However, it still wasn't quite there, and so it's now time to go into phase 2, and let's really bring it to life. These next 3 changes are going to bring this amp to its maximum sound. You can take it from 0 to 10 without blowing your eardrums out, and you've got a decent reverb. It's not my favorite reverb. You've got a beautiful tremolo, and that alone makes this amp the perfect player's amp. What we'll do is I'm gonna film taking the amp apart, because it is kind of a pain in the ass. And the other thing I wanted to show is the speaker. You got to beware of sketchy advertising when you buy an amp as well. And what was advertised as the speaker that came in this was a vintage speaker. It was a vintage Gibson Alnico, and the guy said had one minor hole in it, but that was professionally repaired, and so there's no issues at all. And so when I read that, and I you know, tend to trust that, I go, ah, yeah, whatever, you know, an old speaker with a professional repair, that's cool. It's still from the right time. But what they did is they changed. This originally came with a C10R Jensen speaker, but it was a 25-watt ceramic speaker, and they changed it with a Alnico Jensen speaker, a P10R, I believe. Again, I'll get that right in the editing, but it was truly a 16-watt speaker. So you're playing with fire a couple times. So this repaired speaker was 16 watts in a 15-watt output amp that we want to crank to 10. Especially with the original stuff on it, it's thin. So people would have definitely played it, you know, with louder volume. So we'll have a look at that speaker and we'll see if that matches his description. I have put a speaker in from another amp I had, which we saw. It's a G12M made in UK greenback speaker. The made in UKs were only rated to 20 watts, so it's actually got me second thinking that I need to pull that. Okay, just taking us on another shot of the back here. Let's, you know, nice cabinet construction. That's very obvious. And this, unfortunately, was a homemade, sort of after the fact pedal. Now what came with this that would sit here in a nice little holder was a nice wedged 2-button foot switch, one for tremolo on and off and one for reverb on and off. Because most people sort of set their reverb, perhaps, I know I do, and just leave it while they're playing, the tremolo becomes kind of maybe the most important thing to be able to snap on and snap off. So this pedal it's very cheap, very light plastic, you know, it's just a 1-button tremolo. I kind of want to do something with that. I would like to get my 2-button. The other thing is, you know, the guy's placed it in here. It shouldn't be overly long, but this thing has like, oh no, it does have quite a, yeah, this is okay. This reaches out, you know, 4 feet from your amp. I'd almost want to make something longer. It didn't introduce any noise. This is probably kind of the original length, if not a bit longer. But nonetheless, I'd like something, if I had to go with something, I'd like to replace it with something a little more stout than this cheap, light plastic body and thin-ass die-cast back to it. But it does work, so I shouldn't be too nitpicky about that. Noticing this, it's a brand new 3-plug cord. I did not do that, so someone had upgraded to a 3-prong cord as well when they did the work. So we'll have a look at the quality of that. I think I would have already checked that over when I did my work, and we'll go from there. Also, just a point of note that the amp was missing its back cover. Checked through pictures, and it's a very simple, basically matches this bottom one, which is not removable. It's just a very rectangular piece of wood. Can't get easier than a rectangular piece and 4 screws. This is where the G12M UK Celestion speaker came from. I thought it might be original because of its age, but it is a little bit earlier. So this is a 63 Jensen, 9th week of 1963. So at least a guy found a speaker that was you know, from around the age. But I really knew it wasn't original when I was taking the chassis out of the Falcon, which we'll go through in a minute here, because this bell on the Alnico speaker was preventing the chassis from getting out of it. Just it stuck out too much for the angle to actually get this thing out, and I thought, what the hell? I had to remove the speaker first and then remove the chassis, and that just didn't feel like that would have been done, because you put in, this has got a big ceramic magnet back on it, but once the ceramic's in there, this has got the clearance to tilt the way it needs to and pull the chassis out so you can work on it. So back to this guy, and advertised as you know, good authentic speaker with just a minor pinhole that was repaired. And let's have a look at this thing. Let's have a look at what you actually get sometimes that contradicts what a seller might describe to you. Okay, and for those of you that cringed before in the last scene, the rat's nest, and that was literally a rat's nest, is gone. Thank you, vacuum cleaners. It's really because this speaker is not deemed playable by me, it's really just in here to protect it in case I ever want to recone it. But here's what I got. See how much of that speaker you can see. You know, this is a repair. It looks like a rubberized compound, like rubber compound, which people use, whatever. But it was cracking here severely. It is cracked here and unrepaired. Here was a repair. Here was a repair. There was a repair. There was a big rip there, right from the edge seam down into the woofer cone, you know, main part. There's a repair, and there's a repair. So to me, I mean, hey, maybe that is professional. Maybe that will sound just fine. It didn't sound awful to me. I didn't notice any kind of, you know, there's no cone rub. No cone rub at all. So, I mean, you might deem this to be just fine. Either way, that looked like a few more repairs than one pinhole to me, and the wattage was not correct. So no wonder the speaker blew and continued to crack and blow through its life with this Falcon. Of course, always important to just do hand tight snug on the speakers. You don't want to you don't want to warp them. You don't want uneven pressure. So I always do it hand tight, and I'm just kind of using 2 fingers as my strength or torque limit, and that ensures that, you know, it's secure, it's sealed all the way around, and you haven't over torqued one end to cause damage to the basket, the steel basket, and warping. So that it's snug, but nothing's overly cranked. I mean, this isn't the chassis of a 46 Dodge that you'll be taking Miss Daisy to the parade in. And now that we've seen the state of that speaker and why it had to go, we'll just move over to the main feature of today, and we're going to go ahead and get this chassis out. I thought I would just actually check the tubes before we got the chassis out. So sadly, this nice ICO doesn't list a 6EU4. Before we enter the chassis, thought it was a good idea to check them up front. I didn't check them when I got it. So here's 6E4. Let's do our merit test. Oh, good. So we're very good. That's a very healthy tube, and since I don't have a setting for 6EU7 on here, we're just gonna hope for the best. We'll check the 6V6 and the 5Y3 rectifier next. The 5Y3 is a beautiful RCA from the 60s. Actually, well, yeah, I guess that's 64 and 29th week. So this is the original tube. I would be 99% sure, since it matches the dates on all the other components. Look at how that plate is sort of offset. Well, let's plug it in. Let's hope this is strong, because that is a nice original rectifier tube. So we've triple checked all our settings as usual. I've had it in there for a good minute now to make sure that it's warmed up. got a pretty light glow on the filaments there. You can see on top. And let's see how we do. All right. Oh, we're dropping a little bit. Okay, we're holding at about 89%. It's in the green. Let's see how the other side does. But that's good enough for me. It's workable. All right, 1 2 1 4 1, all ones, 4 1, and just a straight merit test on the other diode. Yeah, a little bit stronger, but pretty even, and we like to see that. We want both sides to be transconducting evenly, so it's about 90, 91, 92, and 89 on the other. So we're happy with that. We have a good 5Y3. Hallelujah. We are checking the 6V6s, and I've left this one in there for a minute, a little bit over a minute, just to make sure it gets nicely warmed up. So we'll begin our test. And the leak test. Excellent. Final merit test. Oh, nice. 120. Beautiful. These are an old Sovtech, and I don't know how old. I don't really know a lot about the vintage Sovtech tubes. And the any kind of indication of a date code or anything is all rubbed off, so it just says Sovtech and 6V6. But looks like we have a winner there, which is great. Let's pop in the next one, and let's hope for good on that. And oops, you never want to assume. You never want to assume, but because we can't check the 3 6EU7 tubes they use in this, pretty critical preamp tubes, we want them to be in good shape. We're just going to have to go, well, the 6C4 was great, and pending this one being great, the rectifier was very good. We're going to have to say, you know what, I bet you them 3 6EU7s are good. And then, let our ears be our guide as well. So here we actually, let's give it a minute. It's always a good idea to give a good solid minute to fully warm up, to let the tube fully start transmitting their electrons to the plate. So here's the second 6V6 tube, and we are ready to check. Good, good. Whole wheat shreddies. That's good. And now the final merit test. Look at that. Perfectly, exactly 120%, just like the other one. So these two are passing their electrons at equal strength, and that is great to see. We're ready to rock. And we've got nice vintagey, if these Sovtechs are vintage, tubes to work with. These old tube testers, when tubes were in everything, particularly radios, and everyone had 2 or 3 radios in their home, like TVs today. These were available at drugstores for customers to come in, and hardware stores. Come in, check your tube, see if it's a tube problem, if your electronic gear started acting up. And so they would bring their tube, and this thing would be plugged in, and they would do their settings, put in their tube, do their checks, and that would tell them if they need to buy a new tube. Now, not all of them, and I'm sure these stores didn't, guide them unless they asked for guidance. Pride of the times would dictate you wouldn't ask for assistance. Looks pretty straightforward, but what's not written is to let them warm up, really give them a good minute, because when I'm hasty and I just give it 20-30 seconds, which is a long time when you're staring at a white screen, they won't transconduct, and your merit shows them as weak. But the truth is, it just hasn't been given enough time to fully warm up, so the filament is getting the cathode to boil its electrons and transmit them to the plate in full force. So very important to just be patient, walk away, let a good solid minute or more pass, and then do your test. Otherwise, you could be throwing away perfectly great tubes, and then waiting 4 weeks and paying a fortune for new ones to come when there was nothing wrong with what you had. And now we begin the fun process of taking out the chassis from this amp. I'm going to keep it laid flat down on its face, and we've got 2 screws over here, we've got 2 screws over there, and 1 on top. So I'm going to do them side to side and then sort of hold it while I get the top out. Remove the speaker wires already. As long as you keep it straight, it's very well measured. Get that out of there. Nope, we can't. So we're going to have to remove the speaker again. I didn't think I would have to do that. But we do. Whatever 16 watt Jensen was in here definitely had a smaller diameter magnet to it, and the way this is designed with an angle slant, it definitely would have just nicely come right out. But we got a big beefy UK speaker in there, and still not going to allow it. So we'll get the speaker out. And I'm just going to put a support screw back at the top just to make sure it doesn't fall or cause any trouble while we're getting the speaker out of there. So, a couple of threads. And here we go. Because this back panel here is fixed, it's actually nailed in and probably glued. It is a little bit awkward to get to these, so nice long multi-adapted contraption like this allows a little bit of wobble so that we can get at them. careful with this because those studs are protruding. Look how beautiful that is. Just freaking gorgeous. Beautiful shape. Because the studs are sticking out in this design, which I am definitely not a fan of, it's very easy if you just get too careless to pierce your speaker cone. That wouldn't be good at all. Getting that out. Okay, there's the beautiful Falcon, and we'll get, I'm going to put a board down, I think, well, let's see, actually that makes a nice workstation. Hopefully those cleats are strong. They're nailed and glued in, so let's hope the engineers thought of the importance of those to hold and support the weight of this chassis. This is a cover, this steel sheet metal here, and it's got kind of a sealing rubbery material that you can see sort of overhanging out here, sticking out, just to keep it nicely sealed. But obviously three of the screws were lost, and there was just 2 remaining. So we're going to take care of that today. I happen to have some sheet metal screws. These are self-drilling, but that's fine. The length is good, and the bite diameter is perfect. So we'll get some nice new hex head screws in there, ×5. So I guess screws are easy to just drop on the floor in your garage and have them run underneath something, and then a guy goes, I'll just put a bag in there too, is fine. And after the screws are removed, we can take this piece out. You see what happens when you decide to be lazy and not put the screws back, is you're just asking for this gasket material to slide and become off kilter. But there's enough seal there to do a great job, especially when we get all 5 screws back. And on the other side we're still looking pretty good there. So that'll go in better than ever. Where's my chopstick? So what we see is, this is the Black Beauty, which people write about, and it is a beautiful black capacitor. A lot of people have said that they're commonly leaky. I did lift the leg, I did check this one, it is perfect, it's not leaking at all. Here are my new filter caps that I replaced those stupid radial ones with. And even though maybe they actually kind of worked pretty good there, by design they would kind of hang straight down, but I do what I do. These are the ones I used, and everything else was looking really great. So other than the electrolytics and changing a cap only because of the value to get better tone out of the amp, better bass response, everything is original, and these resistors held up just fine. 12.5% was their some at their worst, and I'm okay with that. That's close enough, and it was evenly sort of drifted, so I just made the call on that. Everything is in really nice shape. So this is the original big prime filter cap, high voltage, B plus filter cap, and it was really bonded in there. I don't know, with like epoxy or something really tough, and I thought, you know what, I can just leave that. It's not in harm's way, it's not getting in the way of anything, and it looks nice, and it shows the original history of the amp to have the original steel capacitor in there. So at this point, everything is super fantastic. We're simply just going to make our 3 changes here. So just to recap what has been done, this 0.001 was basically like a high pass filter that allowed the higher range of frequency to go through and wouldn't let a lot of bass go through. And we felt that made the amp very thin. I'm going to up the capacitance on this cathode bypass cap in the first stage V1 preamp tube. It's a 60U4 to 25. I know from seeing charts and research that 25 is really where you get kind of a full spectrum of auditory range, so we're going to just make sure we get everything we can out of that. That's why Fender used them. And over here, this is like a 0.1, and I don't know if that 0.1 is just a blotch on the original schematic. It might be a 1 UF, but in either case, changing that to a 25 to make sure all frequencies are passing in this bypass cap is important too. So I'm going to change that to 25. And the third change is this 500 puff. Same thing, we're letting too many highs go, and we're blocking some bass in the final 64 phase inverter tube. So we're going to change that to a 0.002, which is 5 times greater capacitance, and that should be good. Some guys will do more than that, like 0.05, which is 10 times, but 0.002 I think is a great place to start, and we've seen it in other circuits where 002 works excellent there. So I said or an 0047, but I think we'll start with the 02. That's plenty of more bass from its original design. And that is it. When I looked at the tube biasing, the output tube biasing of the 6V6, being that they're cathode biased, 6V6 max plate dissipation is 12 watts, and this was biased to be emitting 11 watts, perhaps just a bit over 11, but anyway, rounded up or down by a smidgen was 11 watts. Close enough to 100%. I have no fear about getting cathode biased right to 100%. I don't exceed 100%, but you know, I say give her. Go from 97.5%, 98% to 100%. Let's get that tube delivering all that it has to offer. So I might up the bias, but you know, in this case, the value and pissing around with this is a 270 ohm resistor. It might put me over 100 because it's pretty close to go higher in value. But I have a feeling that the next resistance value up is going to make it exceed, which is why this resistor was chosen. So main thing, and we should see awesome results, is these 3 minor changes, and it will be brought to life. It will be brought out of its thinly coated veil. Right, so here's the deal with biasing your cathode biased tubes, or rebiasing or adjusting the bias. Because the grid is in reference to ground, which is a 0-volt reference for the circuit, when you raise the resistance to ground in your cathode, you've now given a greater negative reference to the circuit's ground by the grid, and so the grid will register that as a negative voltage. So when you increase the potential to ground, you increase the negative voltage that the grid sees. To me, it's like you're tricking the grid in a way. It doesn't know anything but the reference to ground. So the cathode resistor acts as a intermediate voltage reference, which then becomes negative to ground. So as luck would have it, I did a quick math. 11 watts divided by 12 watts is about 91%, which again is good enough. So I checked the old resistor pile for 2 watt and above, and the best I've got is this 5 watt 330 ohm. So it's probably the next value up from 270 ohm. So we can give that a try. I'm starting to believe that I would have tried that already or investigated that, that it would put it, and it put it over 100%. However, we'll see how this one does to the bias. If not, we're going to be very happy with the factory bias that was set and determined by Gibson, that 11 watts is as close to 100% in this cathode biased amp for a 6V6 that they could get. So we'll see, but yeah, even if it's 102, I'm probably going back to 11 watts just because that's my rule. So just getting my components together, I took a look at the cathode bias resistor, which is right here. It's this 270 ohm. This is a 5 watt, so that's likely not original, or Gibson just had a 5 watt. Put that in there, but here we have the 2 cathodes joined together on the 6V6 output tubes, sharing the 1 cathode to ground. And I thought that's kind of odd choice to ground your cathode to a potentiometer. I mean, it is a good ground. I checked it. It's going to ground very nicely. But right over here is a grounding lug, and it's a very nice ground with a very short distance to chassis, and then you're not putting a whole bunch of extra things on a sensitive potentiometer, which happens to be the depth of the tremolo. I don't know, I wouldn't personally mix that in there. I suppose I'll leave it, but I was thinking it would be a better connection to have it to its own independent ground over here, that's really close to the chassis. Alright, so before beginning to change the components there, I just had to study the pin layout of the 6EU7 quickly, and we see that it's a dual triode, and we see that in one side is going to feed the reverb of V1, and the other side is going to be our first input stage. So I just needed to quickly see where the cathode is and the grid and plate, etc. It's wildly different than the 12AX7, and that makes easy work to trace our signal path on the schematic. So Gibson didn't mark all the pins. A lot of them are cleanly marked, but they didn't mark pins on V2, so I had to determine that grid was pin 8 for the signal path part. The other part is going to serve as the reverb output stage. So I've gone ahead and changed this already to a 25 bypass capacitor on the cathode of V1 of the signal path triode of V1, and then I'm now focused on V2, and we're going to change this 500 picofarad to a 0.002, and we're going to get that cathode bypass capacitor changed from a 0.1 to a 25 UF, and that will complete our work today. So I've gone ahead and got the component ready. So what we see here is that pin 7, which is right here, if you can see it behind this big shielded cable, pin 7 is going over here, and it's going from the plate through a 500 picofarad and on to the grid of the of V4, which is our 6C4 phase inverter over here. And we also see that pin 9 is a area of attention for our cathode resistor and bypass capacitor. So resistor reads very well, so it's in spec. And what we see here is if we exit pin 9, we're going to wiggle over here, it's going to come back here. As you can see, it's very tight, tight spacing, tight area to work with. Very clean though, but there's lots of components underneath these nice strips of resistors. And so where that comes through here, pin 9 goes underneath and it comes over here, and this is our 0.1 capacitor. That's our cathode bypass cap. So we're going to change that right here, as I've put it there to mark me, is the 25 UF. We'll change that. Easy enough. That one's nice access. And then for our plate load our coupling cap. For our coupling cap for our plate, exits pin 7, and it's going to go through a 500 picofarad. So here's pin 9, and exiting pin 7 is this blue wire, and it's coming to attach itself here. And underneath there, if you can see it, is a little tiny red 500 picofarad capacitor. So we're going to change that to this nice Mallory 150 0.002, and I'm going to put some spaghetti tubing around the leads, and because it's quite big and there's no way I'm going to be able to tuck it under there easily without removing 4 or 3 resistors, I'm going to have it mounted as tight kind of above or to the side. So I'll protect these leads with spaghetti tubing and then fold it around, and then we'll tuck it right there, and we'll have a magic amplifier. I got this new gadget just the other day, and it's pretty cool. It was like 20 bucks, and you know, I don't normally check my new components ever, but just because it's super fun, I'm going to check my new 0.0022 capacitor and see what goes down with that. And we have 0.0021, so that's awesome. And why stop there? Let's check the new cathode bypass cap that we're putting in. Because on electrolytics it'll show leakage. And that's a 25 UF, so it's reading 29.69. Low ESR, 0.81 is great. 1% B loss, which I assume is normal, but these are a good quality electrolytic, decent quality, and so they're very good, and that's what good looks like. I have when I got it, I did do some quick kind of comparisons with my multimeter for capacitance, and this will do resistors as well, and it's probably like a 3% accuracy rate. So I trust my meter a little bit better for accuracy, but 3% is just super when you think of how quick this is to test, and how much it'll do. It's a no-brainer. Put your component on, doesn't matter what it is. Hit the test button, and it does its thing. And if it's 3% accurate, that's close enough to know if a component is good. Because when a component is bad, it's bad. All right, and I've got another 0.1 cement disc capacitor to add to the stash, which is awesome. Although I will put this in the bag of my Gibson 64 replaced components. And voila! Just after a little bit of excavation, 2 resistors lifted up and some wires, we got that out. And there we have our changes. So we've got a nice 25 UF bypass cap for V1 for the first stage of amplification of the input signal. We've got a nice 25 UF bypass cap for V2, which was formerly at 0.1. So apparently that choked a lot of good low frequency and wouldn't let any of the full tone flavor we like pass. And then over here was a 500 picofarad that we changed to a 0.002, which we believe will get really great results with. This is before the phase inverter coupling capacitor, and so we believe that we'll get a lot of good tone through there, allowing more lows to pass. So this one was deeply underneath, and obviously it's a bigger film cap than the old little cement one. So we neatly put that on top. The wires are tucked tight underneath and can only spread to the width of the 2 connection points that are on the circuit board, on the terminal board. And also because it's been reaffixed from the top down rather than being on the bottom, with the other 2 components also soldered here. If I wanted to come back in and try the 047, then it's easy to do so, and I don't think that I'll need to. I really think that these, a total of 5 changes, very nice, easy changes to do. And we have ourselves what hopes to prove a wonderful sounding amp, and that's where we're headed to next. Also want to say that I am extremely pleased anytime you can get a vintage amp and your parts, after a service, your parts bag of replaced components is that small. These are very standard electrolytics you change anyway. These tiny little bypass caps. That's just super, and it makes me very happy. This thing is 100% once again. Alright, and just like that, you got yourself a sweet amp. I didn't bother rebiasing or experimenting with that resistor. We've got more juice and flow and frequency flowing through it, and I thought, you know what, it's at about 92%. So I really think the next value would have brought me over 100, and there ain't nothing wrong with this. So this is reverb off, this is tremolo off, with the switch off, and about 3/8 up, and the tone is about 11 o'clock. turn it, turn up a little bit of reverb. Reverb's very sensitive. You don't need more than like 3, but I guess that's pretty common on Fenders as well. Give it a little more. I'll turn it up to half. That's half reverb. Add some tremolo, really nice tremolo. I'm really liking this grid bias tremolo. And I like this because it goes really slow. Come through. That was not there before. So we'll just turn the speed up to half and keep the depth at about half, which is strength. Depth is strength, frequency is speed. And let's see how this does. Strong. Let's get turn the depth down a little bit, turn the speed down a little bit, about 3/8 and 3/8. slow it down a little. Add a little more reverb. If you guys like a little bit more bright, then I'm going to turn the tone up to 1 o'clock. I like a little less tone, a little less bright, but... Full tremolo. Too much, but if I turn the volume off all the way and then I turn the reverb up, there is some kind of cross-linking that puts your input signal through the reverb tank, so there's a little bit of interactive stuff going on. I mean, there would be anyway, but the what should be input off still has got an effect. So there's a link to the volume pot, and the reverb then takes over as sort of a pure wet reverb volume. So that's pretty neat, I guess, in its own way. But yeah, I like the reverb. I mean, you can't go overboard with it, but it's got a very smooth build-up. 1 and 2 is extremely light, and then 3 and 4 is when you start to kind of hear it. Just under 3, so we'll turn it to, let's turn it to 4.5. Pretty cool. And now that we've kind of heard the clean range up to 3/8, all of that was volume at 3.5, kind of just where the sweet spot begins. Let's hear this baby a little overdriven. I think we'll keep the tremolo off, and the tone is now at 12 o'clock, just to get the best of both worlds there. It's actually very nicely balanced, that tone pot at 12 o'clock. Left is bass, right is treble. It's that kind of design of tone. Yeah, she is a beauty.